Hi, Remy here and welcome back. Let's continue on setting up the eddy current sensor. In this video, I'll cover temperature drift calibration, Z offset, and bed mesh. Please check the previous video on how to mount and configure the eddy current sensor if you haven't. Link in the description. Let's start with temperature drift calibration. So before we start, make sure to turn off the AC fan and close the windows to avoid any external airflow effect. Apart from that, there are few configs that we need to ensure are set correctly. So let's see that. Once log in to printer interface, go to machine and go to the configuration file where you have defined the extruder configuration. My configuration is defined in this file, which is sht36v3.cfg. I'll open this file. So this is the extruder configuration. In this, we have to make a note of the max temp. So this value. So this value must be greater than what we are going to use in the temperature drift calibration. So in the temperature drift calibration, if we are using 170C for the extruder, then this value must be greater than that. If you set the same value, then you will get ADC out of range error. Next, we need to adjust or verify the heater bed temperature. So my configuration is defined in this file. So let's open this. Then down over here. So this is my configuration. In this max temp I have set to 130. This must be greater than what we are using in the temperature drift calibration. I'm using 170, so this should be more than that. If we set exactly at 110, then at the time of heating, there'll be fluctuation. The temperature will go more than 110, and that is where you will see the ADC out of range error. So make sure that this value is greater than that. And the last one is to ensure that the stepper Z position min is set to a negative value. So my configuration is defined in this file. Then this is the stepper Z configuration, and the min position I have set to -2. This is required to set a negative value in order to achieve the paper drag test. So this I will show it later while actually doing the test. So let's start. Before that, we'll check the documentation in Klipper website. So we'll go here and look for the command temperature probe calibrate and open eddy current inductive probe link. So this one we need to open. Scroll down, you will find thermal drift calibration. Then under this, we need to perform this task. So this task we need to perform. From here, probe eddy current calibrate. This I have shown in the previous video. Then nozzle must be free from any debris and filament. Ensure that the bed nozzle and the probe are cold prior to the calibrate. If you have just finished printing, wait for a while and then start. Then this task we need to perform if these parameters are not defined in the temperature probe configuration. So this task says that the tool should be at the center of the bed and Z should be around 30 mm. That is the gap between the nozzle and the bed before we start to heat the extruder. So the extruder temperature should be 170C, and once the extruder heater or the extruder temperature is settled, then the gap between the Z, that is the nozzle, and the bed should be around 1 mm. Then this parameter basically says calibration position, where you want to start the temperature, the thermal drift calibration, the position where to start. Then calibration extruder temp, the extruder temp, that is the 170C, and extruder heating Z, that is 30 mm plus. So default value, if you have not defined, then the default value is 50 mm. So I won't be performing this task because I have already defined these parameters in the temperature probe config. So once we have performed this task, we can start with the calibration. For that, we need to execute this command. So this name, that is my underscore probe, we need to replace with the actual name. Target C is 80. That is, once the probe detects that the temperature has reached to 80C, it will perform the final calibration test. You can set the value what you want. Ensure that if you are setting this target to 80, your bed is capable enough to go above 100. Below that, it will take very long time. I have tried it and I could not reach to 80C. Maximum I have gone with 70C. More than that, I was not able to go. It was taking very long time, so I had to stop. Then we need to consider this point. It says that the calibration procedure will request a manual probe every 2C between samples until the target is reached, which means that you'll have to perform the paper test every 2 degree of temperature difference. We can adjust this value. We can adjust this 2C using the step parameter. So if you set this to 4, which I'll be using, then it will request for a manual probe every 4 degree of difference. So that is when the temperature is rising between, let's say the current temperature is 38. So next will be 38 plus 4. So we can start now. Let's go to printer interface, then go to dashboard, and we can execute this command. Here I am using target 56C. This is also given in the Melo website. It says that you can use 56C or higher. I'm using 56C in order to reduce the video time. I've tried with 65 and 70. I was able to do 80. It was taking very long time, so I had to stop. So we can execute this now. But before that, let's see the macro that I have created. So go to machine and macro. And this is the macro that I have created. So here it takes the configuration for temperature probe for the fly eddy probe and saves it here, and then populates this variable. And this variable will be used to populate the user parameter. These parameters we can define in the main cell. We can set in the main cell and run the macro. So then it will home the printer. If not home, set a timeout value to very high value. Then it will set the Z height before hitting the extruder. Then next it will hit the extruder. After that it will start the temperature drift calibration and also hit the bed. So let's start. First I will change the stepper Z position min to 0. We'll go to stepper Z configuration and position min is -2. First I'll change this to 0. This way I will able to show that the gap between the nozzle and the bed, I'm not able to make it as close as possible if set to 0. So save and restart. Then we go to dashboard. Then you can scroll down and here you have edit temp compensation. Click on the drop down. This values remains the same. Desired temperature, set it to 56. Then temperature sample, we set it to 4. Remember, by default it is 2C, that is to request for paper test every 2 degree change. So by setting it to 4, I'll be requesting for every 4 degree change. Then click on send, and in the console we can see the output. Now the extruder is hitting, bed is lowered now. Once the extruder temperature is settled, the bed will be raised and a gap of 0.5 mm will be left. And now you get the pop-up window where we have to lower the nozzle or raise the bed. That is to reduce the gap with the paper test. So we have to leave the gap very less. Once you have the paper test, you need to feel slight drag with the paper. So with this distance left, that is 0.5, it is way too high. That is, you won't get any drag while we are doing the paper test. So let me show that. So we'll reduce this. Now 0.1 is left. I cannot go below than this, otherwise this menu will close. So we'll go by the 0.01. Now 0.005, and this is the maximum height reduction I can do. So with this, if you see, I'm able to move the paper freely and I don't feel any drag. I'm not sure if you are able to see. So let me put the paper again and show. So the gap is too much over here. As you have seen the paper test, the gap is still large. I need to still reduce it, but I'm not able to because there is no more distance left to reduce. So now I will re-enable or set the position min to -2, that is on the negative side, and we'll start the test again. Now let's set a negative value for position min for the stepper Z, -2.0. Save and restart. Then go to dashboard, scroll down, and we'll start with the same place. So you have 56 and then send. So now it has requested for the manual probe. So we'll start with the paper test. I'll lower this. Now again below 0. So since I've set it at a negative value, now it will allow me to go below 0. This seems to be okay. I'll accept. Now it is collecting the first sample data. So the first sample is collected. Next sample is scheduled at 45.10 C. That is the eddy probe temperature sensor. So once this sensor has reached to 45.10, it will start for the next sampling. This is okay. So I'll click accept. So the next sample is scheduled at 59.61 C. So this should be the last one, as we started with as a target temperature is 56. So this is okay. I'll click on accept. So the temperature drift calibration is done. We can save this config. This will save and restart. Then we can go to machine, open printer.cfg, scroll at the bottom, and you will have this new configuration for the temperature drift. So you'll see this configuration. Next, we'll start with Z offset. So for that, we'll revert the changes for the stepper Z. So stepper Z, position min, we'll revert that and we'll set it to 0. Save and restart. Let's start with Z offset. In the last video, I calculated the Z offset from the CAD software, and that was set in the configuration file as a hard value. This will fail if we try to adjust during the first layer as fine adjustment and save it. So let's see how to adjust the Z offset, and for that, I'll use the probe_calibrate G-code command. So once you are in the printer interface, go to the dashboard, then home the printer, go to console and type this command. This will first check the Z and then move the X and Y axis so that to make the nozzle as the center of the bed, and then it will request for a manual probe to adjust the Z offset, which we need to do with a paper test. Actually, I have created a macro by renaming the existing one. So let's go to machine and then macro. So this is the macro. So the G-code command is same, probe_calibrate, and here rename the existing one with an underscore. Then next get the X and Y position from safe Z home, which we know that this is the center of the bed. Then next it will home the printer, if not home. After that, move X and Y to the center of the bed based on the position defined in safe Z home. Then last, it will execute the original G-code command. So why a macro? Two reasons. First, it will home the printer if not home. And second, if you execute probe_calibrate command once again, either after abort or accept, and the tool head is still homed, at this point, actually the nozzle is at the center of the bed and not the probe. So now it will take the current X and Y position as the center of the bed, assuming that it is the probe which is at the center of the bed. Then it will readjust the nozzle to bring the nozzle to the center of the bed, which will actually take the nozzle away from the center of the bed. So let me show what I'm trying to say. So let's disable this macro and save and restart. Then we'll go to dashboard and console and then run this. Now we'll execute this. First it will say you need to home. So let's home it. So now homing is done. We'll start to calibrate. So I'll execute the probe calibrate command. Remember, this is after I commented in the macro. So now a pop-up window will come. So manual probe. Let's say I accept this. Either it's abort or accept. So let's say I accept and then run it again. Now if you see, it is taking the print head back to the back side of the printer. So it is going away from the center. So even if you abort and run it, it will do the same thing. It will again check the Z height at the location where it is. And then from that location, it will move X and Y axis. So that is why I have created this macro. So now let me re-enable it. Save and restart. Now let's see with the macro. So this will first home the axis. Now it will check for Z and then it will move the nozzle to the center of the bed. Now let's say I accept this and then run it again. And now if you see, it will bring the nozzle in front, that is to make the probe as the center of the bed. And if I abort, it should do the same thing. So that was it for the macro. So one thing I forgot to mention, after you execute probe underscore calibrate command, it will ask you to save the config with the save underscore config command. So if you go to macro, I have not included the save config command. So this command I have not included. Reason, this macro or this G code is not a blocking G code, meaning it will not wait for the process to complete. It will also execute this and immediately execute this. So instead of waiting for the manual probe to complete and then execute this, it won't do that because it's not a blocking command. So it will immediately execute save underscore config. So what will happen is once you run this, it will execute this and it will do save underscore config and restart the printer. So it will not work. So make sure don't include save underscore config where the command is not blocking command. Now let's calculate the Z offset. So we'll enter the probe underscore calibrate command. Now start with the paper test. So I will lower this. I can feel the drag, but make sure that the drag is not too much. It should be a slight drag. So I need to increase the gap. That was too much. Do minor adjustment. Slightly increase. So this should be okay. Click accept. And now we can save this, but this will throw an error. So let's see that. So it says that the save config section, probe eddy current, fly eddy probe, option Z offset conflicts. So what we need to do is we have defined Z offset in this particular configuration that we need to disable. So come to machine and my configuration is defined in this file. So I'll open this file and for the probe, I've defined here Z offset of 2.5. I will comment this. Remember, do not save and restart, just save. So don't click on save and restart, just save, then close, go back to the console and type the save config command and enter. So this will save and restart the printer. Now we can go back to machine and then printer and scroll down. You will have Z offset defined here. So this Z offset is almost close to what I had defined in the configuration, that is hard-coded value. So that's all for the Z offset calculation. Now we'll check bed mesh. Let's start with bed mesh. So we'll see basic configuration. We'll go open the printer.cfg file, and then here you have the bed mesh probe count. So this value basically it says how finely the bed is sampled. High value, more detail, and it will take more time. And this can be defined as a single value. In that case, it will take same value for x and y. Use this. Use the single value if your bed is square. If your bed is rectangle, then define both x and y, that is 5 comma the next value. So let's say 5 comma 3. In that case, you have more probes on one axis and less on the other axis. Next algorithm which interpolates the mesh. There are two types: lag range, which is default, and it supports maximum of 6 probe count. That is the probe count over here, max 6. If you have more than that, so let's say 7, this will throw an error. So I'll revert back to 5. And the second one is bicubic. Over here we can mention, instead of lag range, we can mention bicubic. Next we have the other parameters: speed at which to run the bed mesh, horizontal Z move, that is the distance between the nozzle and the bed, it should be 4 mm. Then min mesh, the very first probe should be starting at this particular location. Mesh max, the last probe will end at this location. To run the bed mesh, we need to enter this command, which is bed underscore mesh underscore calibrate. But before that, we need to home. Again, I have created a macro. Basically, this macro says, okay, let's see. We go to the macro and bed mesh. This basically says home the printer if not home, and execute the original command with the parameters that was passed with this G code. Then we can come here and we can execute the bed mesh calibrate command. So when you execute like this, it will run the default method, which is automatic. You can also go to Heightmap over here, and you can do the calibrate. Click on the calibrate button over here. It's one and the same thing. But if you have to pass different method, then this will not work. We need to do it from console. So let's start from console. You go to dashboard, and in console, we'll type this command which says bed mesh calibrate profile automatic. You can give any name. Default name is profile, default name is default. Method automatic, which is the default method if there is a probe detected. If no probe, then default method will be manual. So there are 4 methods. So manual, automatic, scan, and rapid scan. We'll see automatic scan and rapid scan method. For automatic, it will lift the tool, that is, it will either raise the bed or lower the nozzle at each probe point. So let's start. We can enter this command. Okay, it says probe triggered prior to movement, which means the horizontal Z move, what is set as 4, is too low. We need to increase that. So what we can do is we can pass the horizontal Z move parameter while running this command. Bed underscore mesh underscore calibrate will add horizontal Z move as 4.5 and run it again. Now it has started. So it has failed again, which means we still need to increase the height. So we'll set this to 5 and start again. So the automatic one is complete. Now remember, once we run this, this has been saved temporary. In order to save it permanently, we need to run the save config command. So this will save and restart the printer. We'll do this at the end. So I will run the other method as well. So next one will cover scan method. So we'll type this command, and profile name I have changed to scan. So we have different profile, the automatic profile, scan and rapid scan. So method is scan, and horizontal move, we need to set it to 5. So we'll set to lower value, that is 4, and we'll see if it is able to proceed. So we'll start. So basically when you run at scan, there isn't lifting of the tool, that is it will neither raise the bed or lower the nozzle at each probe point. It will only do that at the very first, and after that it will continue to the next point. Just stop, calculate. Without moving the Z, it will move to the next. So now again, this has completed. This time with horizontal Z move of 4, it was able to do. So we'll see if we can lower this value, because lower the value, better the accuracy. So we'll set this to 3. So again with 3, it was able to complete. So I will lower it again. So let's say 2. So with 2, it is not possible. So it needs 3. So I'll try with 2.5. Okay, with 2.5, it was able to do. And then the last one, we'll do rapid scan. So we'll enter this command. So horizontal Z move is set to 2.5. Method rapid scan. And the profile name is also rapid scan. In rapid scan, it will only move the Z at the very first point, and then it will scan the bed. It won't stop at any probe location. From the first to the start, without stopping, it will do the calculation. So let's start with this. So the rapid scan is done now. Now let's see the visualization. We'll go to Heightmap, and then we'll first see the automatic. So this is automatic. Range 2.0 mm, which is very bad. You can see that my bed is warped. It is not good. Then scan, we'll see. It's almost at same range. And rapid, again 2. So this bed is actually not good. I know it's a very thin bed. Basically, I'm using the FR4 fiberglass board. This board is normally which you use for printed circuit board. I have it, which I had purchased when I had got my CR10 S4. That time I had purchased this board, because what you get with the CR10 is a glass, which is again was not good. But this FR4 board was good actually on that. It was working for me. But now over a period of time, it has degraded, and you can see how the depression that is there on that, which is not good. I have ordered for an aluminum bed from AliExpress, which is 8 mm thick. So I'm waiting for that to arrive. There is no point in me doing the print test after the mesh calculation. It's no point, because the difference, the range is very high. I won't get any good result with this. We need to have range of below 0.5 mm to get good result. Now we have seen 3 methods for the bed mesh: automatic, scan and rapid scan. For automatic, I need to have horizontal move Z set to 5, and for scan and rapid scan, I can set it to 2.5. So in my default configuration, that is in render.cfg, under bed mesh, horizontal move Z, I will set this to 5, which is default for the method automatic. So save and restart. And then whenever I go to Heightmap and do a calibrate, this will default to automatic with a horizontal move Z set to 5. And in my start print macro, if I need to use scan or rapid scan, I can set horizontal move Z to 2.5. Please note, if you are using scan or rapid scan method, the height must be significantly low to avoid scanning errors. If you are using rapid scan, it is not recommended to use dense mesh. That is, if the probe points are very close together or the probe count is high relatively to the bed size. That's all for this video. Thank you for watching. Do like, share and subscribe. God bless and stay safe.